This is a tutorial on how to solve the exponential idle Torus puzzle. This is for only the 3x3. So if you want to solve the 4x4 or higher, it will be covered in another video, because 3x3 doesn't have last row parity while the others have. So our method for solving the Torus puzzle is row by row. That means we are doing this row first, then this row, and then this row is pretty much trivial. So basically what we are talking about is how to solve these two rows. The first step is put any numbers in the top row, which is this one. Put any numbers that belong to the top row and are in the top row to their original positions. This is just trivial. So I'll do this, which gives 1. It puts it back into its original position. Now for number 2. Actually, this first row is pretty much trivial, but I'm going to explain it. Here, number 2 is right down here and it needs to go here. As long as it doesn't affect the number 1, we can just slide it there and it doesn't affect this spot at all, which is number 1's space. We can't move it because for now we just want to make 1, 2, and 3 into their original positions. So we just move 2 up, 1 is not affected. Same for number 3. We want to make this move here, and very intuitively we know it's going to go like this. And how do we know it's not going to affect the other pieces? Well, whenever you move in the Torus puzzle, it will only move the pieces on its line. So this time we make 2 movements. It will only move these 8, 5, 4, 9, and 3. So there's nothing wrong. We'll just do this. Now for the second row, which is slightly less intuitive. So right here we have number 4 that we can move here. Again, same as the first row. Move any numbers in the second row to their original positions. If their original place is in the second row and they are in the second row, then you just move them into their original position. Now 4 and 5 are in the second row, so 4 we can move back to its position. But it turns out that for number 5 it can't. So now this is the less intuitive part. So where's 5? It's right here. It's at 3's column. So what we do is move 3 down. We're going to put it back, never mind. And then we don't move it to 5's original column. So we don't move it to its original column. We don't move it to its home column, which is basically the column it belongs to. We move it to the other column because we have 3 of them. So there are only 2 that we can move it to. So there's 1 that can be used. In this case, it's the 1, 4, 7 column. Right here, we move the number 2 down. And then we can move number 5 back and then move this whole row up 1 spot. 2 and 5 will be placed back together. Finally, right here, we have 3 down and 6. If we move it here and we move it up 1 spot, it'll go back to its original position, and so will number 3. So we have placed 2 numbers at a time, like this. And finally, the last row is just very, very intuitive. You just slide it until it goes into its position right here. So now time for an example solve. So right here I've got another puzzle with me, and we follow our method that I talked about just now. So first, move any pieces that belong to the first row and are already in the first row to their original position. Right here is number 3, so we move it back. Now we go according to ascending order. right here, the first number is 1. So we just map it here like this. And number 2 is also really intuitive like that. Now we have completed first row. Second row, first we move any numbers that belong to the second row and are currently in the second row to its original position. So I move number 4 back. Now, so it turns out that number 5 is in its original column. So there are actually 2 columns we can move it to, 1 or 3 column. But we're just gonna choose any one. We're gonna choose the 1 column. And then we can move 2 down, then move 5 back, and then we slot both together. Same goes to 3 and 6, like this. And we're done. So now for some faster solves like this. So if you master it, it's going to look something like that. Yeah, and this method can get you down to less than 8 or 7 seconds consistently. Thanks for watching.